As a final section of this module and the revision classes, I just want to speak about a little bit some aspects of the arid landscapes. So those that are basically deserted, basically dry land, and very often going to be formed by the work of wind, whereas we've seen in some cases also by the work of water, but only seasonally or occasionally. So one of the things that we should know is reasons for aridity. So everything that is about aridity, its causes, or indices, or I just put here the aridity index to make it more simple language. So calculations with the aridity index, and what are the four causes for aridity. Also, we're speaking about sand, so sand dunes, what is the kind of the angle of repose, what is the Brazil knot effect. Definitely we should know these. Also, when we speak about dust, things like the particle size, why or how dust is useful or problematic. And here I want to speak more in details about the Schuster curve. The Schuster curve is really about the ability of materials to withstand forces such as the wind. Why I'm talking about this? Because it's kind of a rule in natural sciences that materials that are very small in particle size can act like something that is tougher. So here what we have is particle size, and what we also have on this chart is then kind of the resistance and what this would look like. It's not a linear relationship, so it doesn't mean that the larger the particle, the more resistance it has. Instead, here we would have clay. The smallest particle sizes of like minerals or grains, and it looked something like this. We have silt and perhaps like sand, much larger in particle size. And so we see that it really is the silt size material that is the easiest, the lowest resistance to forces of like wind, compared to clay or sand that are both much smaller or much larger in particle sizes. This is a relationship then of the Schuster curve. And also what I want to speak about here is the Wasson and Hyde model. I just put here in 1983 because that's when it was published, this work, and so that's how we can refer to the Wasson and Hyde model. And what this is about is then how can we place different kinds of like sand dunes on one chart based on the most important factors that somehow help their development. And so then two factors are present here: the volume or availability of sand, and the other one is the variability in the wind directions. Now this would normally be shown with like an arrow on the x-axis moving away from like the origin, but in this case actually this doesn't exist. Instead we say here we have like a value of 0 and here a value of 1, which would be kind of a total value. And the interesting thing is that we would say that the greatest variability is over here. This is how this model has been developed, so this is how I show it, and just to make sure that we make sure we know what this is about. So sand volume or sand availability and wind variability. So that is about the directions of the wind. And so we had then 4 different types of sand dunes we were talking about. The Barkhan, we said, develops when there's only one wind direction. So this is how a Barkhan would look like. And here we said that there's this kind of wind direction. Only one direction, low variability, but the sand is not available in large amounts. So that's why we'd have something like this: low sand volume and at the same time quite a low wind variability. We'd also have then transverse dunes, and this would be something where we have more sand. We said that Barkhans can be connected, and this is how then the transverse dunes would look like. It's still quite a low wind variability, but the sand volume would be larger, and both we can say that the variability in these values would be quite large, or so it's not going to be so restricted as the Barkhan over here. I've just put some label, transverse. And we said that there would be like the linear dunes where there would be a larger variability in the wind directions. We have at least 2 different wind directions, and that's why we said that we have these kind of lines. So the Sif or linear dunes, and that's why we can put it somewhere over here, because the volume of the sand is low, but at the same time variability of the wind in its directions would be relatively high. And finally, that was linear. And finally, then we would have the kind of sand dune that would have been developed by the largest variability of wind directions and the largest amount of sand, and that would be star dunes, as we call. So star dunes would be something like this. The typical, like what you would have in the Sahara or often in the Taklamakan. So star dunes with the highest amount of sand and the greatest variability of wind. So that's how we can place these different types of sand dunes on the Watson and Hyde model. We might also just want to know, if we speak about the arid landscapes and their land formations, about those kinds of geomorphological phenomena, those formations that I asked you to draw in the portfolio task number 8. And so we definitely need to know what the Zeugen is. So those kinds of rocks that protect the original surface or sediment here. And this would be actually like a witness, so it's from German word witness. This would be the original level of the surface, and the rest has on two sides here been wiped away by erosion. So again, we also need to know yardongs, which are these kind of elongated ridges that are cleaned by these vortices or eddies, winds in between these kinds of ridges. Again, where we have these surfaces that would show the original level of the surface. So at least we should know in details what these are. But also we can think about the pan, and also think about how the tectonically active or inactive areas would be shaped by the factors that mainly form the arid landscapes. So these are just some of the points which I wanted to highlight here, but obviously these are the topics that I most recently been covering, so perhaps it's not necessary to cover these topics so much in details again, but these will be appearing in the exam, at least to some extent as well.